In this video, we're going to talk a little bit about metal properties and identification. And this becomes very important as you start working with any metal piping, tubing, or other pieces of metal. Even if you're not welding, you might be brazing, you might be soldering, but it's really important to know what type of metal you are working with. It's necessary for a welder to have some accurate means of identifying metals. Welders must also have a good understanding of the constituents of metals in order to solve welding problems. Metals are divided into two major groups: ferrous metals and non-ferrous metals. Iron and its alloys are classified as ferrous metals. Ferrous metal classification includes all types of iron and steel, including tool steel, stainless steel, and cast irons. Low carbon steels are a type of ferrous metals most commonly used in welding. Non-ferrous metals include metals and alloys that contain either no iron or insignificant amounts of iron. So the key is the iron. Some of these metals commonly encountered during welding are copper, brass, bronze, aluminum, magnesium, titanium, zinc, and nickel. For iron and steel, carbon steel is an alloy of iron and a controlled amount of carbon. Alloy steel is a combination of carbon steel and a controlled amount of other desirable metal elements. The percentage of carbon content determines the type of carbon steel. Wrought iron has a 0.003% carbon. Low carbon steel contains less than 0.30% of carbon. Medium carbon steel varies between 0.3 and 0.55% carbon. High carbon steel goes much higher, from 0.55 to 0.80, and very high carbon steel is 0.80 to 1.7% carbon. Cast iron contains between 1.8 and 4% carbon. As the carbon content of the steel increases, the hardness, the strength, and the brittleness also increases. In other words, it gets harder, it gets stronger, but it's also brittle. The physical properties of steel and iron are affected by the carbon content, any impurities, addition of various alloying metals, the type of heat treatment. Some of the important physical properties of steel are tensile strength, comprehensive strength, hardness, elongation, the ductility, that's the ability to be stretched, brittleness, toughness, and grain size. Tensile strength is the ability of metal to resist being pulled apart. Comprehensive strength is a measure of how much squeezing force it can withstand before it fails. Hardness is the quality that allows a metal to resist penetration. Elongation is a measure of how long the metal will stretch before it breaks. Ductility is the ability of the metal to be stretched. Okay, other terms commonly used for this are formability, malleability, and workability. Brittleness is the opposite of ductility. Okay, how long? Okay, again, ability of metal to be stretched. This is how the ability of the metal to be broken. Toughness is the ability to prevent a crack from growing. Grain sizes is a measurement of the microstructure of a metal that can be viewed under a microscope. Non-ferrous metals we have to talk about as well. Copper is one of our most frequently, and it's very useful because of its electrical and thermal conductivity and its ability to resist corrosion. Most copper is a reddish brown in color. Copper melts at a temperature of 1981 degrees Fahrenheit. Commercial copper usually contains sulfur, phosphorus, and silicon. Brass is an alloy of copper and zinc. By alloy, we mean a mixture. An amount of alloy can vary from 10% to 40%. A common alloy amount is 70% copper, 30% zinc. Bronze is an alloy of copper and tin. A common ratio is 90% of copper and 10% tin. Now, as we put all of these metals together, there's many more that we haven't talked about. We haven't talked about aluminum. We haven't talked about a number of other metals. But when you're dealing with the welding side of things, most often you're dealing with the ferrous and the non-ferrous ones we've talked about.